Yeah, I would say it's probably approximately normal as well. And
No, because it's out of 50, and we would assume roughly.
not the only reason I would assume it'd be approximately normal. Come on, I want y'all to think a little bit more about this idea that that's my p hat. Why in the world might I think, hey, you know what, this is probably going to be approximately normal?
It's a binomial.
Okay, it is binomial. There's still more you need to say, though.
It's like
The large
natural.
count condition.
Oh, is the large counts condition satisfied here? Is that what you said?
Yeah, that's what I'm trying to say.
Oh, that's what you're trying to say.
And then
Yeah.
10 out of 50 is 20.
Oh, gotcha. Well, remember, she's an 80% free throw shooter, right? So 80% of 50 is 40. 20% then of 50 is 10, right? So we would satisfy large counts. Do notice it's not super normal right now. It's actually a little skewed to the left because it's right on that cusp of the large counts condition. That's why that's happening, okay? Now, as a quick review, a couple of details to remember here is, what kind of distribution did we just construct?
A sampling distribution.
Was it a sample distribution, or is it a distribution of a sample or a sampling distribution? Sampling. Why do we know it's a sampling? There we go. Each dot is a sample. Each dot is a statistic, a p hat. That's why I'm glad we put p hats up here, because each dot is a statistic, right? It is the proportion of successes out of 50 trials. Yes, Madeline?
Isn't there no way to get a full sampling?
Oh, that's right. Thank you for bringing that up. That was the next point I was going to make. Is this a true sampling distribution?
No.
No, it's a, what would we say? Approximate or a partial sampling distribution, okay?
A partial.
So, good note on that. Thank you. Okay, so, make sure you get your little graphs in there. Notice we've already addressed what does each dot represent. It is the sample. That's not the marker I want. What does each dot represent?
Represents spot. The number 50 free throws.
And it doesn't represent 50 free throws. There's something else you're missing with that.
Number of successes.
Which proportion? No, there's another word I'm wanting here.
Population.
Wait, each dot there is a population proportion?
No.
No, it's a
Sample.
sample proportion.
It went in.
That was not true. That did not go in. I could hear that. Sample proportion of free throws Miss Kowalski made. Right, so sample proportion, which notice it's even on the x-axis there. By the way, how do you know I made a halfway decent graph up here? What do I have included, or an acceptable graph?
The titles.
Totals, right? Did I satisfy that? Do I have a title?
Yes.
Do I have units?
Yes.
Do I have labels?
Yes.
And a scale?
Don't say that one backwards.
Alright. So, you good? That's not what I wanted. Star. He's funny. Alright. For an 80% free throw shooter, what is the probability that a sample of 50 shots ends with 64% or less free throws made? So actually I need a 7, 10, 14, 20. That's why I want everyone to have 6. 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 73. What?
How can this be?
So, we did 73 trials.
We missed out on 6.
Quite a few.
Me?
Someone told me 3.
How about the doctor?
You supposed to do 6?
I guess we found the answer. So we have 73 trials here though. If she is an 80% free throw shooter, what is the probability that a sample of 50 shots ends with 64% or less free throws made?
3.
So 3, notice there's 3 that are 64% or less, so 3 out of 73.
Equals 0.0.
Now, I want to pause and I want to point out something notationally. I'm going to use probability notation here because I found last year, or in the spring, I found that this notation helps students understand what's happening here. This is the probability that P hat equals, is less than or equal to what? So 0.64, given what being true?
8 to 8% reload.
So P is 0.8. That's what we just calculated. The probability that P hat is less than or equal to 0.64, given she's actually an 80% free throw shooter, at least by chance alone, right? So what is 3 out of 73, by the way?
Wait.
Oh, you got a whole calculator right there. You're gonna do it on your phone.
0.041109.
No, he's not supposed to have that. Sorry. What was it again?
0.041096.
I got distracted by students doing illegal things in class.
It's quicker.
I'm illegal. No, it's
You're not allowed to have a smartwatch.
It's a painting.
It's the same as having a cell phone.
It's
Send him to the office.
It's
That's what we're about to do.
Yeah.
So, all right, based on your answer to question 6, does Mrs. Kowalski's observed result give convincing evidence for my claim?
Yes.
Why?
Yes.
Because
you're-
you claim that
it's under the
she
5%.
made less than.
It's under the what?
The 5%.
It's under the
It's
5%.
statistically significant.
There we go. So we got some language in here, right? So the probability of P hat being less than or equal to 0.64 by random chance, assuming P is 0.8, right, is 0.04109. More importantly, it's less than what?
The 5%.
The 5% idea. And so we have what?
Statistics significant.
Oh my goodness, statistical significance.
Oh my gosh, I can't see.
Sorry, my head's so bad since I get
Yeah, we need to start.
We knew that one, sorry.
Okay. Ooh, sick burn. Ooh, 6'7".
Okay, you're done.
You're not 6'7". That's a fact. One of my best friends is 6'8". You ain't 6'7". All right.
8.
Yeah.
He's 6'8"?
One of my best friends, yeah.
What is that?
Someone started asking a question.
Oh.
So remember, we talked about this a little bit in the past, where if the probability is low enough, then we no longer think that the original claim was true. It's got to be the alternate. What was that low enough mark?
Is that what you said Wednesday, I
Maybe, but
Yeah.
we've talked about it a few times.
think? Yeah.
We talked about it here, so when we did the 1 in 6, remember that probability of getting 2 or fewer wins by chance alone was 0.016 repeating. That's less than 0.05. I don't think that what their claim of 1 in 6 wins is true. This is only going to happen 4% of the time. That's such a low probability, specifically it's less than 0.05. That is such a low probability, I don't believe her claim.
Right.
I reject her claim. Yes, Madeline?
Is that enough words for like the AP exam? Or-
For a true conclusion? Heck no. We'll talk more about it in a second.
Wait, what was our claim?
What was the claim yesterday?
That.
Oh yeah, you have it right there. She can make
Oh, sorry.
80% of her free throws. What was my claim?
That she could.
That she cannot, that she makes less than 80% of her free throws.
So where's the 0.0419?
That's the probability that, so remember, in the example, she only made 32 of her 50 shots. So what is the probability, like assuming she's an 80% free throw shooter, what's the probability that she only gets 64% or less? Remember, it's always this value or more, does anyone remember the term? More extreme. So it's this or more extreme. So the probability that she makes 64% or less, that's 3 of the 73 trials we ran. What's your question? What's your sure?
This is all. Let's listen to this stuff.
Hey, dude, how likely is it that this happened?
Not likely.
Not likely if she's a 80% free throw shooter. So what do I no longer believe?
But she's not.
She's not an 80% free throw shooter. The idea of statistical significance is there's enough, this is saying there's enough evidence. Think low probability. It's a low enough probability. We reject the original claim. Well, I'll say the null hypothesis. Bless you.
Thank you.
We reject the null hypothesis. Okay, I don't. I need you to meditate, to think on that. Any other quick questions before we continue? No? Okay. Now,
What was that you saying?
alright, so we have some special things we need to name. And we're going to put this on quick notes as well. But this probability right here that we just calculated from this simulation, we're going to call that a p-value. That was the last two questions that weren't supposed to be other than. By the way, Madeline, I remembered what happened. So when I went and deleted the old questions, I saw only 6 there, so I couldn't delete anymore. But I remember AP Classroom telling me there were 8 questions, and I could never figure out where the other 2 were. It was a glitch in the matrix. I really don't know, so I apologize for freaking you out. All right.
I got a bunch of
Yeah, we haven't studied hypothesis tests, much less hypothesis tests for a difference in proportions yet.
It seems easy though.
Oh.
Okay, it is very heavily connected to what we already have talked about. All right, so our p-value is this probability we just calculated. This is known as our significance level. If you are below that value, you're statistically significant. This is the significance level. It is also called alpha.
That's what it was.
Oh.
I thought it was like omega.
No, that's alpha.
Mu alpha theta.
But a different alpha in that mu alpha theta. Because that alpha is the capital Greek letter, this is the lowercase Greek letter.
Alpha means the sigma, right?
It just means first. Alpha is the first letter in the Greek alphabet, and omega is the last letter in the Greek alphabet.
I'm alpha.
That's why they talk about Christ or God being the alpha and the omega, the beginning and the end.
Oh.
And Madeline, what's your question?
Isn't it on, I've got always been 0.05?
It has.
Is it gonna change?
It can.
Wait, our question said 0.01.
It can change.
Will.
We'll learn. So there's 3 main significance levels:
Apart.
0.1, 0.05, and 0.01. We'll talk about why there's those 3 at times. Regardless, if the p-value is less than the alpha, that's when we reject our null hypothesis. Okay, we're going to talk more about that though. All right.
Is
Yes.
there, so is there a mathematical expression that you, when you do plus alpha, that means that it could be more? Does that mean anything?
Not that I'm aware of.
Okay.
All right, hypotheses. Now, when it comes to our hypotheses, remember there is a null hypothesis. Okay? Yeah, these are quick notes. Okay? The null hypothesis, I need you to pay attention to this, is always a statement of equality. The null hypothesis is a statement of equality. What did Miss Kowalski claim?
That she can make 18%.
80%. So, what is she making how could I write that mathematically? If she's claiming she makes 80% of her free throws.
H of 0 equals 8.80.
But how does h sub 0 equal a number? That's just a hypothesis. What is equaling
The probability or the proportion,
the what?
the proportion.
Which proportion?
The population.
The population proportion. Remember, I know the sample proportion. I don't care about the sample proportion. I don't care about the statistic. The question is about the population proportion. Notice that this is a statement of equality with a parameter. So, what could the alternative hypothesis be?
Statement of.
P-hat, P-hat.
Okay, well, not p hat, because I already know what p hat is. Remember, I know what p hat is. All inferences are about a population proportion. So this is a statement of equality, so you're saying it could be a statement of inequality. So what would the inequality possibilities be? Okay, so p does not equal 0.8. That's one of the last ones we'll talk about. What else could it be?
Less than.
It could just be less than
Or greater than.
0.8 or greater than 0.8. It is one of these three. And if anyone's freaking out over the not equal to being an inequality, because we're only used to greater than or less than,
It just means it's not that value.
correct. When a prefix in just means not. So an inequality, just not an equality. So not equal to, greater than, less than are all inequalities. Okay? Do what? Did you have a question? You started to say something.
Oh, no.
Okay.
Just stated.
Now, here's the thing. So, I guess I hate that I did this. So, I said 0.8, but 0.8 was the what? That was the null hypothesis or the original claim, right? So this is I'm going to add this detail here. Okay. This is also what? What value is going to go here?
That's also the null hypothesis.
That's also the null hypothesis.
Why did you write down below the null hypothesis?
Claim. Ms. Kowalski claimed she was an 80% free throw shooter. I doubted her.
How did I be wrong? She's an 80% free throw shooter.
What? I just collected statistically significant evidence that she's not. If she's an 80% free throw shooter, the likelihood that she only gets 64% or less by chance alone is only 4%. She's a dirty liar, huh?
What if she's having a bad day or something?
That's possible, right?
That is
What if you're just
What if
like-
the wrong one?
But here's the thing, even if she was having a bad day, that is still so low to happen by chance alone. I no longer think she's an 80% free throw shooter. Maybe she's close.
She's sitting in her room crying right now.
Good.
Is she your first? Oh wait.
Yeah, she was my intern. I'll let her know that's what you said, Madeline. See how she feels. Yeah, she's my intern. That's right.
Can we zoom her?
No. Okay, so here's the thing though. We actually have a problem with our hypotheses. Anyone know what it is yet?
Wait, what are you saying?
We have a problem with our hypotheses.
It's just,
It has a too little sample.
Hey, guys, we're in a stats class, right?
Oh, we
Oh, there's what? Oh, there's no context.
Gosh.
Make sure, hey guys, when you make this either before or after, you need to define your parameter.
Oh,
Do not ever forget context. Can't ignore the context, guys. Don't ever forget your context.
How could I?
We try to every now and then, Star.
Okay.
We try to. All right. Now, this used to not be a part of the AP exam. The conclusion used to be all that we had to worry about. we now need to add in interpreting, and what interpreting I think does actually improves your understanding of what's happening and makes things easier. So, how do we interpret that p-value? So what was the p-value we calculated?
Oh, shoot.
P
Oh,
equals
nine.
0.4109.
Now, how did we calculate that? What did we do from the beginning?
Sample,
We assumed something.
We assume
We
it should be
assumed that
like
point eight was correct.
Okay, so assuming the parameter, or let's say the null hypothesis. So assuming the null hypothesis was what?
Wrong.
True.
Oh.
Remember, we always assume it's true, right? The null, the original was that they are equal. So assuming the null hypothesis is true, that's the probability. The probability of getting what?
Getting point, or it's
.833
.64 is
0.83
of getting
of
.64.
success.
Well, hold on. What did we calculate this whole time? Probability of getting a
Of,
Success.
.64.
Sample proportion?
so a p-hat sample proportion. Thank you.
Oh.
A p-hat of blank, right? It's going to change per study, per example, right? So probably getting a p-hat of blank or something. Say it again. Or more extreme. Do not forget, it's not just getting that p-hat, because there's a continuous random variable. Probability of getting that p-hat is 0. But the probability of getting that p-hat or more extreme is what? So assuming the null hypothesis is true, probability of getting a p-hat of blank or more extreme is what?
0.8. 0.8.
Well, it was what?
0.8.
No, our null hypothesis was 0.8.
Is greater than the
We already
alpha.
dealt with the or more.
It's true possible. It's super unlikely.
No,
It is super unlikely, but like, how unlikely was it?
No, I meant like, wouldn't you
So-
want
It's
to
No,
do
unlikely, then every.
It's less than 5%
So
likely.
alpha,
Well, yeah, guys, you're making this hard. Like, y'all are kind of jumping ahead. It's just whatever the p-value is.
Yeah, guys, you're.
Isn't that what we looked at, the p-value? Like, remember, don't forget the probability of getting p-hat or more extreme is the p-value. Probably missing a detail here that I need to make sure. Oh no. I was supposed to have p-value earlier.
Yeah, that it's
The
all here, this thing.
probability. Oh, that's what it is. Put p-value here. That's a cleaner way to say it. Sorry about that. The yes. So p-value is the probability of getting. So all that was right. A p-hat of this or more extreme by chance alone. I always put my p-value at the end. The mathematic likes to put it at the beginning, which I get. It makes it a little bit cleaner there. But assuming the null hypothesis is true, and so you would want to say p equals blank, right? So assuming the null hypothesis is true, this is my probability of getting that statistic or more extreme by chance alone. So assuming the null hypothesis is true, this is probability of getting that statistic or more extreme by chance alone. So if my p-value is less than alpha, what do we conclude? Is what we've just done.
there's enough evidence to reject.
It is
the null
statistically
hypothesis.
significant.
There is statistically significant evidence for what? Or to do what?
For the
To
alternate.
reject. To reject what?
No.
The null hypothesis. Now what do we need to put with that null hypothesis? With context.
Always.
Always. So to reject the null hypothesis. So what can we say?
It is not supported.
No, we just rejected the null.
The alternate is true.
We believe the alternate hypothesis to be true. Okay? This is one of the more technical elements. You need to make sure you study these details in this language well and know these things, okay? And I'm going to point out a couple of things in a second. Now, first off, we do need to make sure we attend to this. What if the p-value is greater than alpha?
Then it is.
Then there is
Oh my goodness.
not statistically significant evidence to reject the null hypothesis. We
We believe the null hypothesis to be true.
we can say that, or
You can just say not true.
we don't have enough evidence for the alternative is usually what I would say. So in green is if p-value is greater than alpha.
How in the heck did they decided to do as 0.05 as the statistically significant boundary?
There's something called type 1 and type 2 error, and that alpha is the probability of making a type 1 error. And so we look at and say, hey, what's the probability of making this error? How bad do we think the type 1 error is? Do we think it's bad enough that we make our p-value lower to a 0.01, or do we let it stay at a 0.05? So it's all about what type of error is the worst. Okay. So again, interpreting is important. You need to understand what this p-value means. When I just looked at p-values for the longest time, it didn't make sense to me that if it was less than 0.05 that I rejected the null hypothesis. That felt weird. You need to understand that this is all about assuming the null hypothesis to be true. The probability of getting this, or more extreme by chance alone, is crazy low. And that's what I could have done, is put the is the p-value down here. That's usually what I like to do, is put the p-value at the end. Okay, in a conclusion with a hypothesis test, I need you to always include 4 things.
It's 4 C's.
Nope.
Okay.
You need context.
Where's our not wrong?
Interpretation.
You need to compare something.
Oh, did I never see?
Any guesses?
Contrast.
Compare the
Conclude.
p-value.
The null.
Conclude.
You compare the p-value to alpha. Remember, if p-value is greater than or less than alpha, you have to compare those two. The third statement about, well, this is all about the conclusion, the null hypothesis, and 4, a statement about, any guesses?
The conclusion.
Dude, this is all the
hypothesis.
conclusion. We already have the null,
The alpha.
The alternative.
the alternative hypothesis. You have to include a statement about the null and about the alternative. You gotta have context, and you gotta compare p-value to alpha. You can actually combine it in different ways than what we set up here. Like, I don't memorize this. I make sure I satisfied those 4 things. Okay? So, usually, and actually I think this is what mathematic does. I just say either we reject or we fail to reject. Oh, and that's what we should have said. There is not statistically significant evidence, so we fail to reject. So we either reject or we fail to reject the null hypothesis.
Is our goal to? Wait, hold on.
Our goal is to follow the data wherever it leads.
But fail to reject makes it sound like our whole goal.
We just didn't have enough evidence to reject the null hypothesis. That may be okay, okay? So, we either reject or we fail to reject the null. We will pick up with this on Monday. I don't think any homework, no homework or anything like that, so take a slight break. I do need a couple of us to make up our tests so that I can pass those back ASAP.
Wait,
Monday morning.
Okay,
Mr. Kenny, I have a 0.
wait, I need to retake
for
it.
what?
For, the
DYU?
The unified, DYU.
So I'll replace
No, not the
it with
DYU, not the DYU. The PY.
progress check, easy. Did you do it? Okay, check, if you did,
Was it?
I made a mistake.
It's supposed to be the FRQ though, so.